All right, my lovelies. So today is Tuesday, January 19th. We're going to keep going with our gas laws. Today we're going to cover Gay-Lussac's law, so you should read lesson 105. Last week we did Boyle's law and Charles's law. And then today's graded assignment is gas laws practice January 19th. It's a little longer than a normal exit ticket, so you're going to want to give yourself maybe, I don't know, 45 minutes to work on it, and you do have time to work on it in class today as soon as we're done here. So the question on the board is, when using gas law equations, temperature must be converted to, and the answer is A, Kelvin. In order to get from degrees Celsius to Kelvin, you should add 273. So Kelvin is equal to degrees Celsius plus 273. So let me go ahead and write that in for you. Kelvin, wow, that's really bright, is equal to degrees Celsius plus 273. That's how you make that conversion. If you have Kelvin and you want to change back to degrees Celsius, then you just subtract 273. All right, so Gay-Lussac's law, lesson 105. At constant volume, the pressure of a fixed amount of gas is directly proportional to the temperature of the gas. If the temperature increases, so does the pressure. And if the temperature decreases, so does the pressure. In other words, if one goes up, so does the other, right? If one goes down, so does the other. And you can see that right here. As temperature increases from 300 up to 600, you can see along the way the pressure is also going up 100, maybe 135, 170, right? Almost up to 200. So they are directly proportional to each other. Important word. That means that if one goes up, so does the other. If one goes down, so does the other. And the reason that happens for temperature and pressure of a gas is as the temperature of a gas increases, you are giving it more kinetic energy. As the gas particles have more kinetic energy, they move faster with more energy, and so they bounce off each other with more force. They bounce off the sides of their container with more force, and so that increases the pressure of the gas. And vice versa. If you cool the gas particles down, they lose kinetic energy, they move slower, and so they don't hit the sides of the container as forcefully, and so that is a decrease in pressure. Of course, there is an equation that goes with Gay-Lussac's law, and it is initial pressure divided by initial temperature is equal to the final pressure divided by the final temperature. And just like all of the problems we've done so far, when you have to move the variables around, they just move diagonal across the equal sign. Okay, so for example, if I'm solving for T2, it's got to be in the numerator, which means it has to be up top in order to solve for it, and it has to be by itself, right? It's neither up top nor is it by itself when it's over here, so I can move T2 up, P1 down, and T1 up to get T2 all by itself. And I'll show you that right here on the next slide. Gay-Lussac equation or problem. You have a closed tank of air at a pressure of 203 kilopascal and a temperature of 273 Kelvin. When the tank and the air are heated to 323 Kelvin, what is the pressure if the volume remains constant? So let's write down what we've been given. And I know that I have a pressure right here because it's in kilopascal. And the pressure of the gas in that closed tank is 203 when the temperature is 273. I know that they're in the same sentence. If you read it carefully, it's telling you that these are the initial conditions. So that's a temperature right there. So I know I have a pressure of 203 kilopascal. I have a temperature of 273 Kelvin. And I know those two conditions go together. Those are the starting conditions of my gas. And then the next sentence says, when the tank and the air are heated, so we're changing the temperature, we're raising the temperature up to 323 Kelvin. So that's my new temperature, my final temperature, and the question is asking what happened to the pressure. So I'm looking for P2. So my equation normally looks like this. It would be P1 over T1 equals P2 over T2, but I am solving for P2, which is right there, okay, up top and to the right. The good news is it's already up top in the numerator, right? It's already up here. The bad news is it's not by itself, so I have to get rid of T2. Okay, so I want P2 by itself in the numerator. It's in the numerator, so I don't have to move it down. I don't want to do that. But I have to get T2 out of here. So remember, these variables in these problems just move diagonal across the equal sign to get rid of them or to move them. So I'm just going to take T2 and I'm going to move it up here and put it next to P1. So if I do that, let me grab my pen, I end up with P2 is equal to T2 times P1 divided by T1. Now you could have done that, algebraically. You could have said, oh, well, in order to get rid of T2, I have to multiply both sides by T2, right? That would cancel T2 out over here and puts it up there. And you end up with the same equation, T2 times P1 over T1. So I plug in my numbers. I put 323 Kelvin in for T2. Multiply that by P1, which is 203 kilopascal. Divide that by T1, which is 273 Kelvin. If you notice, see if I can change my ink color here. If you notice, the Kelvin units cancel, and that's good because we're not solving for Kelvin, right? We're solving for a pressure. So if I go ahead and do the math, I get 323 times 203 on my calculator, 323 times 203, and then divide that by 273, and I get, if we count for significant digits, 240 kilopascal. That's a kPa right there. So P2 is 240 kilopascal. So that's how you do it. You're given, right, 3 of the variables and asked to solve for the one that's missing. If you have to move variables across the equal sign, just make sure they move diagonally. And so now you have an opportunity in class to do one of 3 things, or get as many of these as you can done. If you want to backtrack and do some reviewing, I would start here at the bottom and read lessons 101 through 105 if you haven't yet. If you want more practice with Gay-Lussac's law and Gay-Lussac's equation, then I would take a look at doing problems 4 through 7 in problem set 55, and then you can move on to today's assignment, which is gas laws practice, January 19th, and it's 4 questions. 3 of them are calculations, and so you're going to want to have your calculator with you. But this is what you can work on for the rest of class.